Okay, this is a walkthrough through the Intro to Earth assessment for science. Just wanted to go through each question and talk about them so you can help at home. Starting off with number one. Number one, this is the atmosphere. Okay, geosphere is the land, atmosphere is the air, biosphere is living things, and the hydrosphere is all water. So, yes, technically there is moisture in this photo. They're clouds, so it's all moisture, and this would be something that I would actually give to them if they came back to me and they said, "Oh, I said hydrosphere because of the moisture in the clouds," but I don't really think they'd be thinking that deep before they thought of atmosphere. So that was that one. Number two, the two main sources of energy on Earth. That was the sun and Earth's core. We're talking about external sources of energy, not man-made. So we obviously get most of our energy from the sun. The only other source of energy we have that's being generated would be from the heat and pressure on Earth's core. Which is part of Earth's geosphere? Number three, that was granite rock. Ocean water is not land, rain is not land, birds are not land, but granite rock is land. So that was the geosphere. Number four, what is the biosphere? I'm not going to write it, I'll just say the biosphere is all living life on Earth. Plants, animals, fungus, bacteria, viruses, anything that's alive. If they wrote anything that's alive, something along those lines, they got 3. If they identified, if they said, the biosphere is, let's say, the biosphere is the sphere of Earth where all the water is. If they said something to the effect of it's one of the 4 spheres of Earth, they would get 2, because they are partially identifying that the Earth is broken up into these different spheres that we describe, but they didn't describe it correctly, so it wouldn't be a 3, it would be a 2. If it was just completely wrong, it was a 1. If they said it's the rocks, that's a 1. Number 5, which of these layers is home to life on Earth? That would be the crust, the outer core, the mantle, and the asthenosphere are all way below the crust, so obviously we are not living there. Number 6, which of the following is an example of heat energy flowing by conduction? Conduction is the transfer of energy between 2 touching surfaces, so that is actually D. A chef burns his or her tongue after tasting a bite of hot food. The tongue is touching the hot food, and there's a transfer of energy there. Number A, a bowl of soup is heated to a boil in a microwave oven. The microwaves are heating that bowl up, so that is radiation. And both of these, actually, the water in a pot circulates to a uniform temperature, and the person is sitting near a campfire. Those are both actually convection of a liquid and the convection of a gas. So, moving on to number 6. When the water in a pan is heated, the temperature of the water near the bottom of the pan increases. The warmer water becomes less dense and rises through the cooler, more dense water near the top of the pan. In turn, the cooler water near the top of the pan sinks and moves toward the bottom of the pan and begins to warm. What is the effect of the circular motion of water in the pan? So what are we talking about? We're talking about essentially if we have a pan right here, we've got the hot air or the hot water is going to the top, cooling, and then going back down to the bottom. This is by convection currents, right? Not conduction, because conduction is through solid objects touching, and thermal radiation and thermal expansion, we never even mentioned those words in class, so it should have been a toss-up between just A and B for them. So, moving on. Number 8. Name and label each layer of the Earth using the given numbers. 1 is the core. So this is. Oh, I'm trying to. That didn't work. 1. This is the core. 2 would be they could write that down here, but 2 is the outer core. 3 is the mantle, and 4 is the crust. Some of them may have mantle and outer mantle. There's a lot of different ways that it's really split up by depending on who you ask. One thing I said to them is, if you were really studying the composition of Earth as a scientist, and that was your profession, you'd probably have hundreds of different layers you could break it into. But we're just trying to look for the most basic one. And essentially, what we're thinking is that the crust is the hard surface we live on. The mantle is kind of this soupy, everything in the middle where the convection currents are taking place. Then we have the outer core. We have the outer core and the core, or the they probably said inner core. We differentiate between the outer core and the inner core because they are made of the exact same stuff. It's all mostly iron. The difference is the outer core is the outer core is all liquid metal. But as we get closer to the center, the composition doesn't change at all. It's all the same stuff, except the pressure becomes so great that even though it's hot enough that it should be a liquid, it's actually just a super hot solid. Okay. Number 9. Number 9 is radiation. Radiation is the type of energy transmission that doesn't require any matter between it. So that would be the energy from the sun coming to Earth is radiation. 10 is the inner core, and these are actually all the same layers as these. And we talked about the deeper you go, there is more pressure, so the inner core has the greatest pressure. For 11, I don't want to read all these, but we've got A is the correct answer. Most of the answers were either A, or some people incorrectly said C. A is molten rock is heated and rises within the mantle before cooling and sinking back towards the core. And this question was getting at convection currents. And convection currents occur in the mantle. B talks about it, talking about this incorrectly says molten rock is cooled and rises, so that's not right. D says molten rock is cooled and rises again, so that's not right. Things don't cool and rise to the top. B says molten iron is heated and rises within the inner core before cooling and sinking back towards the center of the core. That is describing the same type of process. The important thing to know that is, though, it says molten iron is heated and rises within the inner core, and the inner core is solid, so that is not happening. 12. To get 1 point on this question, it was just totally wrong. To get 2 points, they needed to identify that elevation was the height of an object. And to get 3 points, they needed to identify that elevation is the height of an object measured from sea level. So it has to be from sea level in order to get 3 there. 13. 13 was low elevation and low relief. Obviously, this is like a flat plane right here, so the elevation is low. Relief is talking about the change in elevation, so it's very flat, so that's low elevation. If you look at a mountain, a mountain is going all crazy, that would have high relief. 14, a mountain is a landform with high elevation and low relief. Mountains have high elevation and they have high relief, right? Going back up to this mountain, they've got a lot of change going on with the elevation. So they have high relief, not low relief. So that would be false. 15, the lines on the image represent. These are latitude lines. Longitude is like this, up and down. And the prime meridian is one of the longitude lines. And they do measure degrees, but they don't represent a particular number of degrees. This is the prime meridian, the opposite of the equator. The equator goes across. That red line represents the prime meridian. It's also actually, it is also a latitude line. The problem with the latitude line is we talked just a ton about how, here's Greenwich, England up here, and, the prime meridian is the main one that goes through the very center, so they should have been able to identify that more specifically than a latitude line. It's the prime meridian. Or sorry, it's not a latitude line. I'm trying to think ahead too much. It's not a latitude line, it's a longitude line. But even though it is a longitude line, it is a longitude line, but more specifically, it is the prime meridian. So, 17, this one was D. What you're looking for is we should have a mountain that is higher on the left, right? It's higher on the left than it is on the right, and there's two separate peaks. So this one just looks kind of like it has one peak. This one has one peak it's a little more pointy. This one would kind of look more like this. Actually, let me draw these out for you. This one would probably look like this. This one would look more like that. This one would look more like this. And so this one, we can see it's going up higher and then coming down, and then there's it gets a little higher again. So 17 is D. 18, these are all kind of the same pictures, but the one that changed was this one right here. So we can see this is the one that goes up, but then it's kind of flat and goes down. So the answer to this one was B. A lot of people answered C, but we actually, when we did our little cutout drawings, this is getting really tiny up here, and so they should be noticing that it's going to be a lot more pointy, whereas this one is pretty steep, but then there's a large flat chunk in the middle. So, and finally we have this one, 19. This is, the answer to this is, let me read it first. A topographical map of a small island is shown above. According to the map, point Y is located. So here we have point Y down here, and it is located it's referring to point X. Is it the same? Is it lower? Is it a certain amount lower or southwest? And it is actually, if we follow along our contour line, it's on the same contour line, which means it's at the same elevation point. So the most common mistake on this one was they would say that it's at a lower elevation because they're thinking that, X is up here and then Y is down here. But remember that elevation is shown by these different contour lines that go around like this, and each line is like another slice of the mountain. So that's that. Hope it helps.